we use variable frequency drives. For the inverter, is meant to take up the solar energy, convert it into normal energy. However, in these days, we are doing hybrid controllers, meaning they take both solar and grid power, matches both of them to give the client a seamless supply of water. Then, our controllers are also intelligent, meaning they are connected with multiple sensors to detect the low volume of water in the well and the high volume of water in the tanks. On the other, complementary items are added into the system, be it the DC MCB that will disconnect the power in the line on the event of short circuit or overvoltage. Meaning, the inverter will act as a soft starter for the pump due to the varying solar intensities, meaning the pump will pump variably depending on the solar intensity. Therefore, whichever voltage we receive from or intensity we receive from the solar, our pump will keep running, either at low speed due to the cloudy seasons or at full speed when the sun is fully shining. Then, overnight, when the suns are already set, we use the grid power to continue pumping overnight where the demand is high, maybe in schools, hospitals, or bakeries. But our normal domestic installations, we capitalize on storages, such that what we pumped during the day will be used overnight until the next morning when the sun is shining to replenish what we used overnight in our tanks. Therefore, this gives our boreholes enough time to recharge to the previous water rest levels. In this perception, the solar inverter acts as the favorite solution for rural homes. When they receive dangerously low, it will shut down the equipment to a predefined period of time, which is delayed, to allow the borehole to recharge. And after the elapse of that predefined moment, the controller should wake up on its own until the next dry running session. Okay. Yeah. Meaning, we will have safeguarded the pump to never ever run for the borehole is dry. Right? Yeah. And it should wake up whenever the borehole recharges. Okay. Likewise, if you had a tower or a tank, it pumps out the volume that the borehole recharged until the next dry running session. Program the controller to at least wait for 30 or 20 minutes depending on the recharge rate. Okay. Yeah. So by the time we finish installing, we will pump out and monitor how it is recharging. If it is recharging fast, the lesser the delay, because the pump should lay idle, waiting for the borehole to recharge. Start pumping and up until the tank is full and shut down whenever the tank is full.
Oh, good.
Yeah.
Good.
So that's the purpose of those cables. One is for the power, one is for the sensor. Good.
That's good. So we won't have to be coming out.
You know, Chester, the water was 7 meters up here.
Huh?
7 meters. 7 meters. Like you go 7 meters.
The water is 7 meters down?
Yeah.
The level of the water is 7 meters down?
Yeah.
That's a strong well, yeah?
You have said the inverter converts the solar energy to electric.
Yes.
That is DC to AC.
DC to AC.
And you have said you are using the hybrid inverters. During the night, do we need a store like batteries?
During the night,
yes.
Typically we don't need the battery system. To run an inverter in the battery system is typically uneconomical.
Okay, to run the inverter
with the battery system. Yeah. However, we capitalize on the storages, yes, such that we do elaborate sizing of the pump depending on the borehole parameters when we invest in the required number of solar panels and the equivalent solar inverter, it is capable to give you water and store water in your tanks the whole of the day. Approximately 8 hours of pumping is enough to give you water by the day and until the next morning.
Good.
Yeah.
Now, what of the control panel? How comes the control panel only applied to the electricity, not on solar connection?
Yeah. The conventional controller panels
Yes.
are meant to operate on grid power alone. This gives you an average of between 325 to 400 volts.
Thank you.
Some boreholes have got corrosive water. They can also interfere with the pump.
So if
And
it
the
is corrosive,
cabling.
it means it has acid.
Corrosiveness means, for instance, some boreholes in deeper Rift Baringo have got extremely hot water. So the motor will overheat and blow, and the cable is off. So we might get either the water is too hot, or it has got corrosive chemicals in it. Yeah.
Okay, I get it.
Yeah.
Thank you for explaining. Now I understand.
All right. They are called impellers, the parts that are pumping the water, the rotary parts. So if you service this pump, you open up, you open up this pump, this mantle for instance, and find that these two impellers are worn out, you can replace only these two.
Okay.
Then you salvage the entire pump. If you get it is the shaft that is worn out, you can buy the shaft alone. Yeah, this is the shaft. Yeah. If you find it that it is the valve, because it has got a valve here, you can replace that particular point.
Just the valve.
Yeah.
Okay.
For instance, the pump might be good, but the motor can be blown out. For instance, there was a catastrophe of lightning. So you can just lift and replace the motor alone. You salvage the pump. Yeah.
Sometimes they do quite a lot of casing.
Yes.
And how does that act with these streams? Because to me, okay, with my understanding, probably it's poor, is that if you put those casings and then there are these streams, is it not going to impede the stream to get the water into the...
We use the screen casing or perforated casing to allow water patrol from the aquifers into the bore. So we mix the plain casings and perforated casings.
So the perforation, so that the stream now can flow in.
Yes, through the perforation.
Yes.
The stream can flow in through the perforation. When you do survey, you target the stream of water. The streams. The stream they converge at a place, then they form what's known as a water table. Water table draw water to the source underground called aquifer. Aquifer has a permeable rock. It's a special kind of layer of the soil that hold water. But the aquifer is just to hold water.
So it's more like a rock down
It's a rock down there
holding water.
When we drill this borehole, we pass through several aquifers. Up to when we reach a place, say no, let us stop there. If we go beyond, it will be risky to us. Yes. So from 65, 70, 80, 90 there, we were so careful with the flow of water that was coming. It was coming reddish, brownish, whitish, okay, because of the aquifer or the color of the aquifer that was coming from.
Yes. Okay.